Good morning, everyone. Myself, Rohit Kulkarni. Once again, I welcome you for this session. As you know, we have started our second chapter, periodic classification of elements, and we have continued. We have seen some of the points. Today, we are going to continue the next point. Just before that, I will tell you yesterday what we have seen. Yesterday, we have completed the points such as periods and electronic configuration. Then we have seen its valency and how the periodic trends are observed in the modern periodic table by taking some of the activities. Right now, today we are going to continue from page number 25. Our point is atomic size. Right, all of you can see on the screen. If you have textbook with you, you can open page number 25. So see what is our next point: atomic size. You have seen in the previous standards that size or volume is a fundamental property of matter, and the size of an atom is indicated by its radius. So atomic radius is the distance between the nucleus of the atom and its outermost shell. Now see what is given. The atomic size of an atom is indicated by its radius. And what is atomic radius? Atomic radius is the distance between the nucleus of the atom and its outermost shell. So whenever we are drawing any diagram, so during that time, the distance between the nucleus of an atom and its outermost shell, it is called as what? Atomic radius. You can take any element and you can draw the structure and you can find out. Now say atomic radius is expressed in the unit picometer, short form is PM, which is smaller than nanometer. So 1 PM means 1 picometer is equals to 10 raised to minus 12 meter. So you should know this, the conversion. Atomic radius is expressed in the unit picometer, which is smaller than nanometer. And 1 picometer is equals to 10 raised to minus 12 meter. Clear? So this is just an introduction. So if in this, you can remember the definition of atomic radius and its units. Clear? Now we'll see some of the activities to understand more about it. Now see what is the first activity. Some elements and their atomic radii are given here. So you can see one slide is saying that you can see some elements given, and below that you can see the atomic radius, which is given in picometer. So just first we'll go through that. See oxygen, boron, carbon, nitrogen, beryllium, and lithium. And below that you can see the atomic radius. Now see, you will find that atomic radius goes on decreasing while going from left to right within a period, and the reason behind this is follows. Clear? So for that, we'll see one activity. First we'll complete this and then we'll see one activity. The reason behind this is follows. While going from left to right within a period, the atomic number increases by one, meaning the positive charge on the nucleus increases by 1 unit at a time. However, the additional electrons get added to the same outermost shell, and due to the increased nuclear charge, the electrons are pulled towards the nucleus to a greater extent, and thereby the size of the atom decreases. Clear? Yesterday we have seen, in the last bit we have seen that the atomic number increases by 1 unit as we move from left to right in a period. Clear? And while going from left to right within a period, what happens? The atomic number increases by 1, and it means the positive charge on the nucleus increases also by 1 unit at a time. Now see the activity, use your brain power. By referring to the modern periodic table, find out the periods to which the above elements belong. Right now, whatever the elements are given, oxygen, boron, carbon, nitrogen, beryllium, lithium. So what you can do, you can open page number 23 of your textbook and you find out where these elements are there. Clear? So these elements are in the period second. All the elements such as boron, oxygen, carbon, nitrogen, beryllium, and lithium. So they all are in the period 2. So you can see the answer for that. It is written the above elements belong to period 2. Clear? So this is the first answer. Now see what is the second. Second question, arrange the above elements in a decreasing order of their atomic radii. Now we are going to arrange the above elements in the decreasing order. So the above elements in a decreasing order of their atomic radii. So first will be lithium, then beryllium, after that boron, carbon, nitrogen, and oxygen. And below that, the atomic radius is written, that is, it is arranged in decreasing form, that is from bigger to smaller. Clear? So you can see the atomic radius is also written below that: 152, 111, 70, 88, 77, 74, and 66. So all the elements are arranged in the decreasing order. Does this arrangement match with the pattern of the second period of the modern periodic table? Right? Now see what is the third question. Does this arrangement match with the pattern of the second period of the modern periodic table? This arrangement match with the pattern of the second period of the modern periodic table in a decreasing order of atomic radii. Just you can open page number 23 and you can check there. So first is lithium, clear? In the periodic table also, second period. Beryllium, then boron, then carbon, then nitrogen and oxygen. So by looking at the periodic table, we can say that this arrangement matches with the pattern of the second period of the modern periodic table in a decreasing order of their atomic radii. Then question number 4. Which of the above elements have the biggest and the smallest atom? So that you can find out by knowing the atomic radius. So the biggest atom is lithium, okay, because its atomic radius is 152. And the smallest atom is oxygen. The smallest atom is oxygen. Now, what is the periodic trend observed in the variation of atomic radius while going from left to right within a period? While going from left to right in a period, atomic number increases. Already we have seen this, that while going from left to right in a period, the atomic number increases, atomic radius decreasing. Remember this, while going from left to right, what happens? The atomic number is increasing and atomic radius is decreasing. Therefore, atomic size gradually decreases. So therefore, what happens? The size of atomic size also gradually decreases. Clear? So this is about one activity. Clear? Now we'll see the second activity. Now we'll see activity number second, which is given on same page number 25. Now see which are the elements: potassium, then sodium, then Rb. Right, you can see all the elements which are given, that is potassium, sodium, rubidium. Clear? These all are elements are there, and below that the atomic radius is given. Now see what is the first question. By referring to the modern periodic table, find out the groups to which above the elements belong. The above elements belong to group 1. Clear? Just look in the modern periodic table which is given on page number 23, and you can see these all elements. Right? They are belong to the group number 1. Right? That is potassium, rubidium, cesium, lithium, and so all the elements are there. Now, arrange the above elements vertically downwards in an increasing order of atomic radii. Now, whatever these elements are there, that we are going to arrange in the increasing order of atomic radii, means from smaller to bigger. So the first one is lithium, second one is sodium, third one is potassium, fourth one is rubidium, and fifth one is cesium. Right? So these all elements are arranged in the increasing order of their atomic radii: lithium, sodium, potassium, rubidium, and cesium. And below that, the atomic radius is also written. Now, question number 2. Does this arrangement match with the pattern of the group 1 of the modern periodic table? This arrangement matched with the pattern of the group 1 of the modern periodic table in an increasing order of their atomic radii. Now, this, whatever the arrangement is there, it matches with the group 1 of the modern periodic table in an increasing order of the atomic radii. Clear? So, maybe you understood the difference. In period, it also matched, but in the decreasing order of the atomic radii, and whatever the elements are given here, it is matched with the group 1 of the modern periodic table in an increasing order of the atomic radii. Now see what is next question. Which of the above elements have the biggest and the smallest atom? So this we can find out from the activity. The biggest is cesium and the smallest is lithium. So it is written the biggest atom is Cs, that is cesium, and the smallest atom is Cli, that is lithium. Then fifth question. What is the periodic trend observed in the variation of atomic radii down a group? So while going down a group, atomic number increases and atomic radius also increases. Therefore, atomic size gradually increases. So while going down a group, what happens? Atomic number increases. In the same way, atomic radius increases, and therefore atomic size gradually increases. So the first activity was about period, and the second activity was about groups. Clear? So maybe you understood the difference of both the activities. Right? Now see last point. You will find that while going down a group, the atomic size goes on increasing. So after looking at both the activities, we can understand that while going down a group, the atomic size goes on increasing. This is because while going down a group, a new shell is added. So why it happens? Because while going down a group, a new shell is always added. And therefore, the distance between the outermost electron and the nucleus goes on increasing. So that is why what happens, the distance between the outermost electron and the nucleus goes on increasing, and we call it as atomic radius. And as a result of this, the atomic size increases in spite of the increased nucleus charge, right? And as a result, what happens, the atomic size increases in spite of the increased nuclear charge. Okay? So this is about atomic size. So go on once again, you can go on through both the activities, and you can revise that. Clear? Now we'll move on page number 26. That is next point is metallic and non-metallic characters. Now on, if you can see, there is also an activity given, use your brain power. First we'll see the question. Look at the elements of the third period, classify them into metals and non-metals. Right? Now the elements in the third period are sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. If you look in the modern periodic table, so these all are the elements in the third period. Then, on which side of the period are the metals, left or side? So left or right? So left side of the periods are the metals. So whatever the left side of the periods are there, they are all the metals. Yes. And on question number 3, on which side of the period did you find the non-metals? So right side of the periods are the non-metals. So remember that left side of the periods are the metals and right side of the periods are the non-metals. Clear? I will see more in detail about this metallic and non-metallic character. It is seen that metallic elements like sodium, magnesium are towards the left. Clear? You can open page number 23 to understand that. You can see the sodium and magnesium. These elements are towards the left. And the non-metallic elements, which are such as sulfur, chlorine, and are towards the right. So whatever the non-metallic elements are there, such as silicon, phosphorus, sulfur, chlorine, argon, right? These all are what? These are towards the right. And the metalloid elements, such as silicon, lies in between these two types. So whatever the zigzag line is there, yesterday also we have seen whatever the zigzag line is there. So that are what? That are the metalloids. And on the left hand side, all are metals, and on the right hand side, all are the non-metals. So the metalloid element silicon lies in between these two types. A similar pattern is also observed in the other periods. It is seen that the zigzag line separates the metals from non-metals in the periodic table. So the zigzag line in the modern periodic table, it separates the metals from non-metals. Clear? Now further, elements appears to have arranged in such a way that metals are on the left side of this line and non-metals on the right side, and metalloids are along the border of this line, right? As I already told you, the same point is repeated. It is seen that elements appears to have arranged in such a way that the metals are on the left hand side and non-metals on the right side, and metalloids are along the border of this line. How did this happen? So we'll see further. Let us compare the characteristics, chemical properties of metals and non-metals. Whatever the properties that we are going to consider. It is seen from the chemical formula of simple ionic compound that the cation in them is formed from a metal while the anion from a non-metal. So you can underline that, right? It is seen from the chemical formula of simple ionic compound. Last year in 9th standard we have seen how to derive the formula. So what we can see that a cation in them is formed from a metal, while the anion form a non-metal. So from this, it is understood that metal atoms have a tendency to form a cation by losing its valence electron, and this property is called electropositivity of an element. You can underline this if you have textbook with you. So from this, what we can understand that metals atoms have a tendency to form a cation by losing its valence electron. So metal, it loses its valence electron and they have a tendency to form a cation, and this property is called as electropositivity of an element. Understand the point. On the other hand, an atom of a non-metal has a tendency to form an anion by accepting electrons from outside into its valence shell. Clear? And just opposite, on the other hand, an atom of non-metal has a tendency to form an anion. Means non-metals have a tendency to form an anion by accepting electrons from outside into its valence shell. And we have already seen that ions have a stable electronic configuration of a noble gas. Clear? Understood what is the electropositivity, that how the metals have a tendency to form a cation and non-metals have a tendency to form an anion. Clear? Metals accept the metals they lose electrons, and non-metals they accept the electrons from outside. Clear? Now, one more question is given. How is the ability to lose or accept electrons in the valence shell determined? Now see, all the electrons in any atom are held by the attractive force exerted on them by a positively charged nucleus. So whatever the electrons are there, means all the electrons in any atoms, they are held by attractive force exerted on them by a positively charged nucleus. Electrons in the inner shell lie in between the valence shell and the nucleus. So whatever the electrons are there in the inner shell, they lie in between the valence shell and the nucleus. And because of their presence, the effective nuclear charge exerting an attractive force on the various electron is somewhat less than that of actual nuclear charge. So because of their presence, what happens? The effective nuclear charge exerting an attractive force on the valence electron is somewhat less than the actual nuclear charge, and thus the number of valence electron in metals is small, that is 1, 2, 3. So that is why the number of valence electron in metals is very small, means it is 1, 2, 3. Means whatever the valence electrons are there which are present in the outermost shell, mostly 1, 2, 3, whatever they all are will be metals. Also, the effective nuclear charge exerting attractive force on the valence electron is also small. In the same way, the effective nuclear charge exerting attractive force on the valence electron is also small. And as a combined effect of these two factors, metals have a tendency to lose the valence electron to form cation having a stable noble gas electronic configuration. So because of these two reasons, clear, metals have a tendency to lose the valence electron to form a cations and having a stable electronic configuration, noble gas configuration. And this tendency of an element is called electropositivity and it is the metallic character of that element. So remember that. What is the metallic character of the element? That metals are electropositive. And further, we are going to see the non-metallic character, that non-metals are electronegative. Remember this. Clear? So from these two paragraphs, we have understood that how the metals are electropositive. That is why electropositivity is the metallic character of that element. Now on page number 26, one periodic table is given, periodic trends in element. That we'll see further. Means we'll complete these 2 points and then we'll move on that chart. Means whole concept will be clear for you. Now see on page number 27. Now we have completed about metallic characters. Now we'll see about non-metallic character. Now the periodic trend in the metallic character of elements is clearly understood from their position in the modern periodic table. Now whatever the periodic trend in the metallic character of the element is there, it is observed. We can see it is seen from the position in the modern periodic table. So for that, what we are going to do, let us first consider the metallic character of elements belonging to the same group. So for that, what we are going to do, we are going to consider some of the elements belonging to the same group. So while going down a group, a new shell gets added, resulting in an increase in the distance between the nucleus and the valence electron. Right? In the last activity, we have seen that while going down a group, what happens? A new shell gets added. And because of this, what happened? It resulting in an increase in the distance between the nucleus and the valence electron, and that is outermost shell. And this resulting in lowering the effective nuclear charge and thereby lowering the attractive force of the on the valence electron. And because of this, what happens? This results in lowering the effective nuclear charge and thereby lowering the attractive force on the valence electrons. Right? So these all are theoretical part you should read and you should understand. As a result of this, the tendency of the atom to lose electron increases, and because of this, what happens? The tendency of the atoms to lose electron is also increases, because we have seen that metals, what they do, they have a tendency to form a cation by losing its valence electrons. As a result of this, the tendency of the atom to lose electron also increases, right? And because of this, what happens? The tendency to lose electrons also increases. Also, the penultimate shell becomes the outermost shell. So whatever the shell is there, it becomes the outermost shell on losing valence electron, and the penultimate shell is the complete octet, right? And when the outermost shell loses its electron, so whatever the shells are remain, means the outermost shell will become a complete octet, and therefore the resulting cation has a special stability, and therefore whatever the cation is formed after losing the electron, means the positive charge, it will have a special stability. Due to this, the tendency of the atom to lose electron increases further. The metallic character of an atom is a tendency to lose electron, and therefore the following trend is observed, that the metallic character of element increases while going down the group. So metallic character, so this is still about metallic character. So from this, what we can say, the metallic characters of elements increases while going down a group. Clear? So understand about metallic character and what happens in the group. So first and the most important thing is that metals have a tendency to form cation by losing its valence electron, and this property is called as electropositivity, right? And the electropositivity is the metallic character of that element. And the third, what we can see in short, that metallic characters of the element increases while going down a group. Clear? So this is about group. Now page number 27, we'll see the second paragraph. Now we'll see about periods. Now we have seen about groups, now we'll see about periods. Now see, while going from left to right within a period, the outermost shell remains the same. While going from left to right within a period, the outermost shell remains the same, because we have seen yesterday also and now also, that as we move down in a group, the number of shell increases. But as we move from left to right within a period, the outermost shell remains the same. The outermost shell is not changing. Just I will tell you one example. If you see the periodic table, second period, for example, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So all these elements have only two shells. Clear? So the outermost shell remains the same. No number of shells is added. But as you go down in group, the number of shell will increases. However, the positive charge on the nucleus goes on increasing while the atomic radius goes on decreasing, and thus the effective nuclear charge goes on increasing. So because of this, what happens here? The positive charge on the nucleus goes on increasing while the atomic radius goes on decreasing, and thus the effective nuclear charge also goes on increasing. And as a result of this, the tendency of atom to lose valence electron decreases within a period from left to right. So that is why what happened in a period, the tendency of atom to lose valence electron decreases within a period from left to right. Okay, now this you can just see in page on page number 26. The chart is given 2.10. Now you can see in that chart, all it is shown with the colors. The metal, which is shown with the blue color, then the metalloids, light gray, and the non-metal, it is shown with the dark gray color. So by looking at the figure, you can understand which are the metals, which are the metalloids, and which are the non-metals. Clear? And now the arrow is shown. The arrow is shown which is moved towards the right hand side. So above that you can see decreasing atomic radius. Clear? Now only we have seen that point. That however, the positive charge in the nucleus goes on increasing while the atomic radius goes on decreasing, and thus the effective nuclear charge goes on increasing. So that's 3 points. So decreases atomic radius, increasing electronegativity and non-metallic character as we move from left to right in a period, and decreasing electropositivity and metallic character. And as we come down, means in a group, what happens? See, it increases atomic radius. If you understand the chart, whole metallic and non-metallic characters will be easy for you. Then second point, decreasing electronegativity and non-metallic character. It is just opposite in the periods, in the groups. And third one, increasing electropositivity and metallic characters. Yeah, just see for the periods what are the characters, and just see for the groups what are the characters. Now see what is the third paragraph. The two factors, namely the increasing nucleus charge and decreasing atomic radius as we go from left to right within a period, are responsible for increasing the effective nuclear charge. So the two factors, namely, so which are the two factors? The increasing nuclear charge, clear, and decreasing atomic radius as we move from left to right within a period, are responsible for increasing the effective nuclear charge. And therefore the valence electrons are held with greater and greater attractive force, and this is called electronegativity of an atom. Clear? And due to increasingly electronegativity from left to right within a period, we have written there, if you can see the page number 26, it is written there, increasing electronegativity and non-metallic characters. So the same point is given here. Due to increasing electronegativity from left to right within a period, the ability of an atom to become anion by accepting electrons from outside goes on increasing, and the tendency of an element to form anion or the electronegativity is the non-metallic character of an element. So this is about the non-metallic character. So the tendency of an element to form the electronegativity is the non-metallic character of an element. Clear? So this is about metallic and non-metallic character. Now all these points we'll see in short. That is, it is given in always remember. Clear? But before that, once again, I just want to revise the chart which is given on page number 26. So as I told you, from left to right, as we move in the period, what happens here? Decreasing atomic radius. So atomic radius decreases. Then electronegativity increases and non-metallic character. And third point is decreasing electropositivity and metallic character. And as we come down in a group, see what happens. Increasing atomic radius, just opposite of that. Decreasing electronegativity and non-metallic character. And third point is increasing electropositivity and metallic character. So look at that chart which is given on page number 26, the modern predictable trends in elements. Clear? And read whole whatever things are given and just try to understand. Now see whole two we'll see in short. Now always remember, while going downwards in any group, the electropositivity of elements goes on increasing while the electronegativity goes on decreasing. Understood? Whenever you are going downwards in any group, what happens? The electropositivity of the element goes on increasing, and while the electronegativity goes on decreasing. Clear? Now, while going from left to right in any period, means now we are moving from left to right in any period, the electronegativity of the element goes on increasing. Already we have seen this point, and you can write down this statement if the because it is very easy. While their electropositivity goes on decreasing, just is it is opposite in groups and period. In group, what happens? The electropositivity of elements goes on increasing, and electronegativity goes on decreasing. And in periods, what happens? The electronegativity goes on increasing while that of electropositivity goes on decreasing. Then third point, larger the electropositivity or electronegativity of the element, higher the reactivity. Yeah, if the electropositivity and electronegativity rate is larger, then the elements have high reactivity. So whole thing means metallic and metallic characters you can understand from this three points that which is given in the always remember section. So clear? So once again, just I will repeat. While going downwards in any group, the electropositivity of elements goes on increasing while their electronegativity goes on decreasing. Then while going from left to right in any period, the electronegativity of element goes on increasing while their electropositivity goes on decreasing. Clear? So see, first and second point, they just opposite. While going down in a group and while going from left to right. And the third point is, larger the electropositivity or electronegativity of the element, higher is the reactivity. Clear? Now, we'll see, use your brain power, which is given on page number 27. Now see, what is the first question? What is the cause of non-metallic character of elements? So these questions are based on this metallic and non-metallic character, whatever things we have seen from page number 20 on page number 26 and 27. So see, what is the first question? What is the cause of non-metallic character of elements? So see the answer. The tendency of an element to form anion or electronegativity is the non-metallic character of an element. Already we have seen the answer for this. So learn it by it. The question is, what is the cause of non-metallic character of elements? So this is just a 1 mark question. So the tendency of an element to form anion or the electronegativity is the non-metallic character of an element. Okay. Now we'll see second question. See, what is the second question? What is the expected trend in the variation of non-metallic character of the elements from left to right in a period? Now this is about period. Clear? Already we have seen that. What is the tendency observed? In a period, as the atomic number increases from left to right, electronegativity increases while the electropositivity increases and non-metallic character decreases. Already we have seen that. And this is due to the decrease in the atomic size. So this is expected trend observed in the non-metallic characters of elements from left to right in a period. So once again, I will repeat the answer for that. In a period, as the atomic number increases from left to right, electronegativity increases and non-metallic character also increases, and this is due to decrease in the atomic size. And why this happens? This happens because of the decrease in the size of atomic size. Clear? Now question number 3. See what is question number 3. What would be the expected trend in the variation of non-metallic characters of elements down a group? Now we are going to see about down in a group. In a group, as the atomic number increases, electropositivity increases while electronegativity decreases, and non-metallic character also decreases. Clear? The same thing is repeated again and again. So maybe about 3 to 4 times we have seen the same thing. Maybe all of you are bad till now. So in a group, as the atomic number increases, electropositivity increases while electronegativity decreases, and non-metallic character also decreases. Clear? So these are the answers for the use of brain power. Once again, just I will repeat that all the 3 questions and 3 answers. See what is the first one. What is the cause of non-metallic characters of elements? So answer for it is the tendency of an element to form anion or electronegativity is the non-metallic character of an element. Clear? Then second question. What is the expected trend in the variation of non-metallic character of elements from left to right in a period? So the answer for it is, in a period, as the atomic number increases from left to right, electronegativity increases, non-metallic character increases, and this is due to decrease in the size of atomic size. And the third question is, what would be the expected trend in the variation of non-metallic character of element down in a group? So the answer is, in a group, as the atomic number increases, electropositivity increases while electronegativity decreases, and non-metallic character also decreases. Clear? So this is about metallic and non-metallic characters. Clear? Now we'll see the next point, that is gradation in halogen family. This is the last point. Now see the group 17. Right now, just if you can open the modern periodic table, in that you can see the group number 17. So these all are halogens. These all are what? They all are the members of halogens, like bromine, fluorine, chlorine, bromine, iodine, astatine. Right. So these all are what? These all are comes under the group of halogen. So that only we are going to see. So the group 17 contains the members of the halogen family, and all of them have the general formula X2. Remember this, the halogens have a general formula, that is X2. Now, a gradation is observed in their physical state down the group. So all these are down in the group number 17. For example, fluorine, chlorine, bromine, iodine. So gradation is observed in their physical state down the group, and thus fluorine, remember the formula for fluorine is F2. Don't write only F, it is F2. Chlorine, Cl2, they are gases. Remember, fluorine F2 and chlorine Cl2, they are gases. Bromine Br2 is a liquid, while iodine I2 is a solid. So you should know this, that whatever the halogens are there, means fluorine, chlorine, bromine, iodine, out of that fluorine and chlorine, that is F2 and Cl2, they are gases. Then bromine, that is Br2, is a liquid, while iodine I2 is a solid. Clear? Fluorine and chlorine are in gaseous form, bromine is in liquid form, and iodine is in solid state, or it is in solid form. Clear? So this is what gradation observed in the halogen family. Now just we'll see the last point, that is do you know, which is given on page number 28. Now see, one reaction is given there, M plus 2H2, that is MOH twice plus H2. Now see, a general chemical equation indicating the reaction of alkaline earth metal is given above. So whatever the reaction equation is given above, chemical equation, that is an general chemical equation which indicates about the alkaline earth metal, which is present in the group number 2. While going down the second group, as beryllium, magnesium, calcium, selenium, and barium, the gradation in these chemical properties of the alkaline earth metal is seen. These all metals elements are present in the group number 2, that's alkaline earth metals. While going down the second group, the reactivity of the alkaline earth metal goes on increasing, and thereby the ease with which this reaction takes place also goes on increasing. So as we move down in a group, second group, whatever the alkaline earth metals are present, the reactivity goes on increasing, and therefore the ease with which the reaction takes place also goes on increasing. And when they take part in chemical reaction, it also goes on increasing. Thus, beryllium does not react with water. Remember this, all the point. On page number 28, it is given. Beryllium does not react with water. Magnesium reacts with steam, while calcium, strontium, and barium reacts with water at a room temperature with increasing rate. So these all are the elements which are present in the second group. So the beryllium does not react with water. Magnesium reacts with the steam, while calcium, that is Ca, and strontium, Sn, and barium, Ba, it reacts with water at room temperature with increasing rates. Right. So this is about do you know. Clear? So here we have completed our topic. That is topic number second, periodic classification of elements. Right. So we have seen the classification elements. We have seen Doberener triads, Newland's laws of actives, Mendel's periodic table. All the statements you have tried, you have to study merits, its demerits. Then we have studied about the modern periodic law, modern periodic table, how, what is groups, what is periods, how many groups are there, periods are there. Then we have seen the electronic configuration of first 20 elements, its symbol, its atomic number, its valency, and where they are present, and what is the periodic trend observed in groups as well as in periods. Then we have seen about different shells, that is K, L, M, N. Clear? And today we have seen the about atomic size. We have seen the two activities, that and about atomic radius. And the last point we have seen about metallic and non-metallic character, and about how the gradation seen in the halogen family. Clear? So here we have completed our chapter. Now what you have to do? Whatever the exercise is given on page number 28 and 29 of the textbook. Clear? So you have to write down that all the questions and answers in the notebook, and you have to learn that. Clear? Because this lesson is very important from the exam point of view. If you have any doubts regarding today's session, you can ask it. If any students have any doubts, and as I told you, the homework, all of you know the today's homework, that whatever the exercise is given at last, that is on page number 28 and 29. All the questions answers you have to write down in the notebook, and you have to learn that. Try to find out by your own, because already we have whatever the objectives are given. Try to find out the answer by reading the textbook, because already we have seen all the points. Clear? So you can ask any doubt is there. 2 minutes are remain. You can ask it. Hello, madam. If any student is asking any doubts, let them ask, because already I have completed my.
Students, those who are raising their hand, unmute yourself.
हेलो सर. हेलो सर.
Yes.
सर सर वो जो
You can ask.
सर वो एटॉमिक साइज है, एटॉमिक साइज के नीचे वो येलो बॉक्स में एलिमेंट्स लिखा है और एटॉमिक रेडियस ऑफ पीएम लिखा है. सर वो नंबर्स की मीनिंग, मतलब नंबर्स क्या क्यों लिखा है, वो समझ में नहीं आया सर. 66
दैट इज एटॉमिक. हाँ, एटॉमिक रेडियस है उसका. एटॉमिक रेडियस मतलब फॉर एग्जांपल ऑक्सीजन का. एटॉमिक रेडियस मतलब क्या है? डिस्टेंस बिटवीन द न्यूक्लियस ऑफ द एटम एंड इट्स आउटर मोस्ट शेल. सो ऑक्सीजन का एटॉमिक रेडियस है 66.
यस सर, थैंक यू सर.
हाँ, एंड इट्स, और उसका शॉर्ट फॉर्म भी हमने देखा है. पीएम मतलब पिकोमीटर एंड एनएम मतलब नैनोमीटर. And the conversion also is given. 1 picometer is equals to 10 raised to minus 12 meter.
Okay, sir. Thank you, sir.
Okay, welcome. Again, anyone have any doubts? Hello. Hello, madam.
हेलो सर.
हाँ, yes.
सर आइए 2 मिनट कैमरा ऑन कर देंगे.
Why?
सर कुछ दिखाना है आपको.
No, मतलब मैं कैमरा अभी मेरा स्क्रीन शेयर किया है मैंने. क्या पूछ सकते हो आप? क्या पूछना है आपको?
सर जो एटॉमिक पीरियोडिक टेबल है.
पेज नंबर. हाँ, ओके, कंटिन्यू. हाँ, पूछो.
पीरियोडिक टेबल में जो साइड में नंबर दिया 1, ये हाइड्रोजन का 1.008, ये एटॉमिक नंबर है या मास है सर?
कौन से पेज पे? Just tell me the page number. See here, you can follow the modern periodic table which is given on page number 23. Page number 23 पे जो modern periodic table दिया है वो follow करना है. उसमें आपको atomic number भी दिया है. हाइड्रोजन का ऊपर लिखा है right corner में 1, so that is atomic number. So if you go further, helium atomic number 2 जो ऊपर right side corner में दिया है. So
yes,
they
sir,
are the atomic number. वो atomic
yes.
number है उसका.
And sir mass? सर मास, एटॉमिक मासेस जो साइड में नीचे दिया है.
हाँ, correct. So that will be your atomic masses. It is given in points. So no need of studying that. Just go through that is given for extra information. आप सिर्फ उसका एटॉमिक नंबर, आपके लिए अभी क्या इंपॉर्टेंट है वो बता दो. आप उसका एटॉमिक नंबर, उसका सिंबल, फिर उसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन और उसकी वैलेंसी, फर्स्ट 20 एलिमेंट्स हाइड्रोजन से लेके कैल्शियम तक, उतना करो बस. आगे का आपको जब आप आगे जाएंगे 11th में तब आप कर सकते हैं, लेकिन अभी सिर्फ आपको 1 फ्रॉम एलिमेंट 1 to 20 उतना ही इंपॉर्टेंट है.
यस सर.
ओके,
थैंक यू सर.
ओके, वेलकम.
Okay, so we'll stop here.
Yes, ma'am. Okay.
Okay.
Thank you.
Thank you so much.